Grade 8, Chapter 3, Understanding Quadrilaterals. Let us see what is a plane. A plane is a flat surface, just like a paper, that has no thickness. A plane contains many lines and extend without end in the directions of all its lines. Here in the figure you can see this is a horizontal plane, this is a vertical plane, and this is a combination which is showing you both horizontal and vertical planes. You can name a plane by either a single capital letter or by at least 3 of its non-collinear points. Here you can see vertical plane, it is denoted with a single capital letter, or else you can denote it using a 3 non-collinear points. A paper is a model for plane surface. Next one, what is a curve? A plane curve is a curve that lies in a single plane or a plane surface like paper. A plane curve may be closed or open. Here you can see these are examples of closed curves, means there is no opening at any point, whereas these are the examples of open curves. See, here there is opening, here, here and here there are openings. So these are examples of open curves and these two are examples of closed curves. When we join a number of points without lifting a pencil from the paper, you get a plane curve. Let us see what do you mean by a polygon. A closed figure that has vertices and sides made up of non-overlapping line segments is called as a polygon. Here, if you take this triangle, these points are called as the vertices, and a closed figure that has vertices and sides, see, these are the sides. When you join those points, you get a triangle made up of non-overlapping line segments. Here you can see there is no overlapping. Okay, means crossing like this. This line is overlapping with this line at this point. But whereas in these figures, you can say no line is crossing the other line. That is, no line is overlapping the other line. So all these are called as a polygons. We can also say a simple closed curve made up of only line segments is called as a polygon. For example, take a circle. It is not having any opening point. It satisfies the definition that a closed curve that has vertices and sides. It is not satisfying the definition. It is not having any vertices and it is not having any sides, and it is made up of non-overlapping line segments. Here you can observe that it is not made up of overlapping line segments. So this cannot be called as a polygon. A polygon is a closed figure formed by a finite number of lines, means either 3 lines, 4 lines, 5 lines, like that. Each one is given one name. If the polygon is made up of 3 lines, it is called as a triangle. If it is made up of 4 lines, it is called as a quadrilateral, and so on. If it is made up of 12 lines, it is called as a dodecagon. Okay, so here in the figure you can see with 3 sides, triangle, 4 is quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is heptagon, 8 is octagon, 9 is nonagon, 10 is decagon, 11 is hendecagon, 12 is dodecagon. We even have many more names depending upon the sides. which you will see in the higher classes. Let us see what is a diagonal. A line from a vertex to a non-adjacent vertex is called as a diagonal. Here, in a square, these are the vertices. He said that a line from a vertex means if you take ABCD, come to point A, vertex A, to a non-adjacent vertex. This is adjacent vertex and this is the adjacent vertex for A. So only a line can be drawn to C, which is a non-adjacent vertex. In the same case, if you take B vertex, A is adjacent and C is adjacent. So a line can be drawn only to D. Come to C. Adjacent vertices are B and D. So a line can be drawn only to A. Come to point D. Adjacent vertices are C and A. So a line can be drawn only to B. So in a square there will be only two diagonals. Whereas in a triangle, see, you can observe there will be no diagonals. There are 0 diagonals. In a pentagon, there are 5 diagonals. In convex simple polygons, diagonals always be within the interior. Now, what is a convex polygon? If it is a closed polygon, here see, this is example of a convex polygon and this is example of a concave polygon. So in a convex polygon, all the angles should be less than 180 degrees, as you can observe in this figure. All the angles should be less than 180. All the diagonals should be inside the figure. If you draw diagonals, they will lie only inside the figure. Parallelogram, rectangle, square are all the examples of a convex polygon. Whereas coming to concave polygon, it will have at least one angle greater than 180 degrees. Here you can observe this angle. This is greater than 180 degrees. See, this angle is also greater than 180 degrees. The statement says as at least one angle should be greater than 180 degrees. So here two angles are greater than 180 degrees. So it becomes a concave polygon. And also the statement says as a concave polygon should have one diagonal, at least one diagonal outside the figure boundary. When you draw diagonals, see, these diagonals are coming outside the figure boundary. So it is a concave polygon. This is the main difference between the convex and concave polygons. What are interior and exterior angles? Let us see. In this figure, inside the figure boundary, the red colored angles are called as the interior angles, whereas blue colored angles which are lying outside the figure are called as the exterior angles. Angle sum property of a quadrilateral. We know angle sum property of a triangle, that is, sum of all the angles of a triangle should be equal to 180 degrees. Here you can observe in this quadrilateral there are two triangles. Always in a quadrilateral there will be two triangles. Take any figure of a quadrilateral. See, for example, if you have taken a figure like this, it can be divided into two triangles. So 180 is one triangle and other triangle angle sum is 180. Total if you add 360 degree you will get. So always sum of four angles of a quadrilateral will be equal to 360 degrees. Depending upon the figures, the number of sides in that figure, how do we find the sum of angles? Here you can observe in the first one there are 3 sides and the angle is 180 degree. As all of us know, the sum of all the angles of a triangle will be equal to 180 degree when you sum up. When there are 4 angles, see this is 180 and this is 180 degrees. Why? Because it is divided into 2 triangles. So 2 into 180 degree you can do to find out the angle sum. 2 can be written as 4 minus 2 into 180 degrees. The same way, when you have 5-sided figure, it can be divided into 3 triangles. Here I have written the sides. Angle sum will become 3 into 180 degrees. 3 because this is the number of triangles into 180 degrees common. Just like here, the 2 are the number of triangles into 180 degree. 3 can be written here as 5 minus 2. So here you can observe every time we are writing number of sides. If you take number of sides as n minus 2 into 180 degree, if you do, we are getting the angle sum of any figure. Using angle sum property of a quadrilateral, he is asking us to find x value here. In this figure, it is given 90 degree here. As it is a straight line, the total angle will become 180 degree. As it is already given 90 degree, so the other sided angle becomes 90 degree. Now, sum of all the angles, if you add, it should be equal to 360 degree. So we know 90, 60 and 70 degree, and x angles, if you add, it should be equal to 360 degree. Here you can see, if you sum up, it will be equal to 220 degree plus x value, that will be equal to 360 degree. So when you solve it, you will get x value as 140 degree. Coming to next question. Here also he asked us to find out x value. In this figure you can see there are 5 sides. Okay, let us find these 2 interior angles also. Total angle will be 180, so the interior angle becomes 180 degree minus 70 degree, that is 110 degree, and the other side, this angle also will become 180 minus 60, that is equal to 120 degree. Okay, so angle sum of a polygon formula, as we discussed, n minus 2 into 180 degree. Using that, how many are the number of sides? That is 5. So 5 minus 2 into 180 degree. When you solve it, you will get 540 degree as the answer. So sum of all the angles, when you add up in the given figure, it should be equal to 540 degrees. So adding all the angles like 30, x, and 110 degree and 120 degree should be getting 540 degree. That is what I have equated here. When you solve it, you will be getting x value. Next one, here he asked us find x in the following figure. Before solving it, I would like to say you sum of exterior angles of any polygon. Let it be a triangle, let it be a quadrilateral, let it be a pentagon, any triangle, sum of all the exterior angles, when you sum up, it should be equal to 360 degrees. Using that, sum of all the 3 angles means here it is given 125 degree and 125 degree and x as the exterior angles. When you add up all this, and when you equate it to 360 degree and solve it, you will be getting the x value. These are the types of polygons and their properties. Not the types of polygons, it is the types of quadrilaterals. What is a quadrilateral? Quadrilateral is a 4-sided closed figure which is made up of only line segments. Parallelogram, rectangle, square, rhombus, trapezium and kite are examples of quadrilateral. Here let us discuss properties of this parallelogram. Opposite sides will be equal to each other and they are parallel to each other. In a rectangle, opposite sides are equal and parallel, and also all the angles are right angle, that is each angle measures 90 degree. Same like a rectangle, each angle measures 90 degree in a square. All sides will be equal, opposite sides will be parallel. In a rhombus, opposite sides are parallel, all sides are equal, opposite angles are equal, and diagonals bisect each other at right angles. Trapezoid, we can also call it as a trapezium. It has only one condition, that is one pair of opposite sides is parallel. Kite, two pairs of adjacent sides are equal, one pair of opposite sides are equal. One diagonal bisects the other. Diagonals intersect at right angles. Let us see how we will solve this question. Find the measure of each exterior angle of a regular polygon of 9 sides. As we discussed, depending upon the number of sides, the angle, using that, sum of all the angles of a regular polygon will be equal to n minus 2 into 180 degree. Standard formula we are writing. Here number of sides represents n. Given number of sides is 9. So 9 minus 2 into 180, when you solve, you will be getting 1260 as the answer. He asked us to measure each of the exterior angle. So we need to divide. So we need to first find out what is the each interior angle. For that, what we did, 1260 divided by 9, that should be equal to 140 degree. Each exterior angle he is asking us, not the interior angle. So exterior angle and interior angle at any point, if you sum up, it will be equal to 180 degree. So 180 degree minus 140 degree, when you do, you will be getting 40 degree, which is the measure of exterior angle of this regular polygon having 9 sides. Next one, the following figure GUNS and RUNS are parallelograms. Find x and y. In this parallelogram, as we discussed the property, the opposite sides will be equal to each other. So 3x will be equal to 18. When you solve, 3x is equal to 18, you will be getting the answer as 6. Again 3y minus 1 is equal to 26. Again when you solve it, you will be getting a y value as 9. The same model. Next bit. In this parallelogram, the diagonals bisect each other. So diagonals bisecting each other means from that intersecting point, the measurements of both are equal. So let us equate y plus 7 is equal to 20. So y value becomes 13 here. Now substitute this 13 here. Why? Because x plus y is equal to 16 here. When you substitute y value as 13, what happens? X value becomes 3. So 3 comma 13 are the measures of x and y. So these are few models which we discussed in this chapter. Thank you.